Where is everybody? Finally starting to be some fall weather. It's kind of nice. I thought on the radio, I thought they were just saying overnight. Maybe it's this weekend. I wasn't paying that close of attention. They said 2 to 4 inches or something like that. Yeah. You guys probably weren't even alive. Yeah, you weren't even alive when we had the blizzard and I think it was 91. Halloween got canceled across the state. Yeah. Yeah, right around Halloween. Yeah. Well, let's finish this example, and then the 8 of you may get more bonus points. I don't know. Friday's the last day for withdrawal. Is that right? It would be, but it's been. Well, they had their high school. That doesn't mean that they'll have class here, but. Yeah. Who knows? What's that? 3 to 5. I'm not 100% sure on that, but at least 3. I don't think there's more than 5. And yeah, they're the ones that show up fairly often, or besides you 4. Okay, so I think we had our arithmetic right to this point. And we're just going to factor this a little further. You probably can't see the black. Or at least not very easily. Okay. So let's factor out a 2. And you get 2x squared plus 9 minus 11 with an x there. Need 2 numbers that multiply to be negative 22 and add up to be positive 9. What are the 2 numbers? Yeah, I'm going to use 11 and 2. So if I multiply these 2 guys together, that's my AC. I need 22, so I need factors of 22 that add up to be the middle term. So I'm going to use 2 and 11. We'll go plus 11x, and then I'm going to go minus 2x minus 11. And we'll factor this by grouping. So if I group these first 2 guys together and these guys together, I end up with 2. I can factor out a x from that first thing and a minus 1 from the second thing, and each time I get an a 2x plus 11 times an x minus 1. X plus 1 squared, x minus 3 squared. Okay. This was my derivative, right? Let's maybe review what we were actually doing. Okay. So we wanted to find, we want to split the domain into intervals based on the critical values, and then we're going to assign a plus or a minus to each interval based on whether it's increasing or decreasing, determined by the derivative. We're all good with that? What we were planning on doing with this problem? Okay, so let's take a number line here. And this is a fraction, rational function. And so it's got roots when the numerator has roots, and it has asymptotes when the denominator has roots, right? If the denominator is 0, you get an asymptote. If the numerator is 0, you get a root. Okay, and it's already in simplified form. Nothing's going to cancel. It's all factored out, so it's really easy to read off what's going to happen. So my denominator at -1 is going to have an asymptote. So on my number line, I'm going to put an asymptote at -1. At 3, I'm going to put an asymptote. I have a root at 1, and I have a root at -5.5, -11 halves, right? From this. So at -5.5, I have a root. Okay. And then I just need to figure out, is this positive or negative on these intervals, right? Okay, is the function going to be increasing or decreasing on these intervals? So I'm going to take a test value from over here, from in here, from in here, from in here, from in here, and we're going to determine what the derivative looks like on those pieces of the domain. Okay. So let's put in something that's less than -5.5. And if I do something less than -5.5, that means 2 times it is less than -11. So this would be a negative value in that first place in the numerator, right? Okay. I also take a negative and I subtract 1 from it. It's still going to be negative there. And it turns out that the denominator is going to be positive no matter what we put in because they're squared, right? So the denominator is not going to tell us anything. It's just going to be what do the two things in the numerator do? And they become positive. So this interval over here is going to be a positive interval. Okay. Let's find one that looks like it might write in a color. Okay, so now I'm going to take something that's in here. So it's between -1 and -5.5. So it is smaller negative than 11. This is going to be a positive bit if I put something in there in. You good with that? Okay. So it'll be positive there. And x minus -1, that will also be negative still because I'm taking a negative number and I'm subtracting 1 from it. Denominator is still positive. So this bit, this interval is going to be negative. All good there? Okay. This root that I crossed over, what it did was changed this minus sign to a plus sign here because it was dealing with this factor, which is the root that I crossed over. Kind of notice that? Okay. When I cross over this asymptote, the thing that will change from this plus minus plus setup will be the factor that's associated with this asymptote. That factor here, if I'm on the left of -1, that factor is negative. If I'm on the right of -1, that factor is positive, right? So that's the factor that changes, but because it's squared, nothing here changes. Kind of good with that? So this is still going to be negative here because the factor that changes was squared and it's not going to change the negativity or positivity of the result. Okay. Crossing over this root, the factor that changes will be this one, right? Since that factor changes from negative to positive, all of the things here are going to be positive now. And so this will be positive on this interval. Crossing over this asymptote, the factor that changes will be this factor. It's always positive, so nothing actually changes. I'll stay positive there. Are we all good with how I sort of shortcutted through that computation stuff? Okay. So our intervals of increase and decrease. Intervals of increase are where it's positive. So that's going to be between 1 and 3. And between 3 and infinity. I don't include the asymptote here, right? Because I can't, right? You can't include the asymptote because it's not in the domain of the function, so it can't be increasing there if it doesn't even exist there. Intervals of decrease. We would have negative infinity up until negative 5.5. And we would have negative 5.5 up to negative 1. Oops, sorry, I missed one, didn't I? This is not correct. I have this green interval over here, right? So that should go up here. And negative infinity up until negative 5.5. And then these two, these are negative 5.5 until negative 1, and negative 1 until 1. And that should take care of everything. Negative infinity to negative 5.5, negative 5.5 to negative 1, negative 1 to 1, 1 to 3, 3 to infinity. So yeah, that takes care of the entire real line. Where do we have questions on this?